Once you set up your hypothesis, then we need to start talking about how the hypothesis test is performed. Okay, last section was talking about confidence intervals, and this is very related to confidence intervals. In fact, they say very similar things. Okay, so here we've got the level of significance. Okay, sometimes you call it like your level of tolerance. For example, if we went back to the example of trying somebody at a court of law and you were sitting in the jury, you have to decide for yourself at what point does the level of evidence reach a certain point and you switch from being the default to thinking the person is innocent to thinking the person is guilty. So this is like the level of tolerance. It's also called the level of significance. Okay, so everyone's got a different tolerance. Everyone has a different level of significance. It's true that you can actually choose your level of significance, which is called alpha. Okay, this is again very related to confidence intervals. When your alternative hypothesis sign is the not equal to sign, then you have two tails, okay? Because it's possible to be greater, it's possible to be smaller, because you're just saying it's not equal. So it could be greater or smaller, in which case you would have 1 minus alpha, which is confidence level, and level of significance, your tolerance level or your error rate, will be divided into two tails. This is called a two-tailed test. If you're testing a one-way relationship, so here if the sign in the alternative is the greater, you can see this is an upper tail. We do not have to divide the amount of error into two. There is only two sections. There's 1 minus alpha and there's alpha. So you don't have to divide your error in two when you've got a one tail. Here you've got the possibility also of having a lower tail test. So here's upper tail, here's lower tail. This is when the sign in the alternative is the less than sign. You've got alpha in the lower tail, 1 minus alpha, or the confidence in this side that always contains the middle. Okay, so that's the idea. That's the shapes that are going to come. Now we need to go from setting up our hypothesis into actually deciding which hypothesis appears to be supported. So we're going to have to collect all of the information, all of the sample, all of the evidence that we've heard into one value so that we can actually assess whether or not we think the null hypothesis appears to be supported. Okay, so this is called making a test statistic. Okay, a statistic is just a compilation from a sample, and the test is just referring to the fact that it's a hypothesis test. So we're going to convert all of our data into a test statistic. Then we will convert the test statistic into something called the p-value. Okay, and the p-value is a little bit difficult to understand. So here's an example that I wrote up. I think it's a really good example, so let's go through it. The p-value means, what it refers to is the possibility of repeating sampling processes and comparing likelihoods of those theoretical results from what actually happened. Okay, so that probably doesn't mean a lot to you. Let's look at this example here. Okay, so here's an example. I've got a basic understanding of what I think ginger ale costs. So here, if my favorite brand of ginger ale is on sale for a great price, I will buy an exorbitant a quantity of it because I expect when I go shopping later, it won't be that price again. Okay, so here I have an idea, a null hypothesis of what I think this pop is going to cost. When I see evidence, when I'm in the store and it's on a super good sale, then I am noticing that something rare has occurred here. I've seen normal things and I've seen now this rare special case, and I want to identify that by saying, whoa, something's weird here, and my original hypothesis might be incorrect. So the p-value then, formally what it means, it's defined as the probability that if the null hypothesis is true, you could collect another sample. You could go out again and see something as rare or more rare than the sample that you've actually got. Okay, so this is important in knowing how to interpret the hypothesis test. Is a very big part is understanding the p-value. Okay, so the p-value says that if the null hypothesis is true, the p-value is actually the probability of seeing a sample more strange than the sample that you just got. Okay, so it's like saying I went out, I saw the price of pop was $7. then fine, I went out again. The probability that if the pop really does cost $7, and the probability of me going out and seeing pop that costs something way more extreme, like $17, then that is the p-value. It's the probability of seeing something more strange than the sample if the null hypothesis is true. Okay, what it means. So that's the definition of the p-value. What it means is it will tell us which decision to make. When the p-value is greater than or equal to alpha, okay, then we will fail to reject the null hypothesis. Okay, what this means then, so here's an example a student said to me. Let's think of the hypothesis like a job interview. Okay, so you're interviewing for a job. Your null hypothesis, of course, is that you will be offered the job. Okay, so you believe you're going to be offered the job. That's why you showed up to interview. Okay, so the analogy would be like this. If the null hypothesis is that you will get the job, then the p-value is the wage that they offer you to pay you for that job. So you're going to say, well, if the wage is large enough, if it seems like it's a fair compensation, then you will accept the job. You will, quote unquote, accept the null hypothesis. We don't actually say that. We say we would fail to reject the null hypothesis, but quote unquote, accept the null hypothesis if p-value is large. However, if the p-value, if the pay is small, so you interview for this great job and everything seems wonderful, and then they tell you that they're going to pay you minimum wage, then if you've seen that there are people that are getting paid more for that than that for that job, then you'd say that p-value is too small, that pay is too small, and I am not going to accept your job offer. I'm going to reject that job offer. Okay, so when the p-value is smaller than alpha, we reject the null hypothesis. When the p-value is larger than or equal to alpha, then we will fail to reject the null hypothesis. Okay, so decisions are always based in terms of the null hypothesis. We either fail to reject the null hypothesis, which is like accepting it, or we reject it, which is like rejecting it. Okay, what this means, so if we accept, quote unquote, the null hypothesis, this means that HA doesn't seem to be supported. Okay, the alternative doesn't seem to be supported by the data. And if you reject the null hypothesis, it means the alternative seems to be very supported by the data.